video, let us learn how to test the solar panel to the inverter and run the load. This video is split into two parts. Part 1 will cover the testing of the solar panel, connecting it to the battery, charge controller and power inverter, and rest in part 2.
At the end of this video, you will be able to test the solar panel, connect the battery to the charge controller, connect the power inverter to the battery, connect the solar panel to the charge controller. Let us collect the tools, equipments and materials required to do this practical. Trainees toolkit, digital multimeter with props, moving coil ammeter 0 to 15 amps, solar charge controller, type PWM, system voltage 12 to 24 volt, maximum output current 50 amps, power inverter with user manual, output power 300 watts, input 12 volt DC, output 220 volt AC, solar panel 12 volt 100 watt with manual, battery 12 volt 10 ampere hour, AC lamp load 240 volts 100 watt with holders and connecting wires, SP/ST switch 6 amps 250 volt, DC circuit breaker single pole 12 to 250 volts DC 6 amps, connecting wires 1.5 square mm and 6 square mm as required, square millimeter and 1.5 square millimeter as required. Testing the solar panel. Safety precautions. Observe polarities when connecting solar panels and batteries. Photovoltaic panels produce electricity when exposed to light, so it is recommended to cover the front of the solar panel at outdoors to help avoid shocks. This is particularly important for higher voltage panels. Open circuit test. Disconnect the solar panel completely from the battery and charge controller. Position the solar panel towards the sun or any light source. Set the digital multimeter to measure DC voltage at 20 volt range. Identify the positive and negative terminals of the solar panel on the back side, usually indicated with positive and negative signs as shown. Place the positive probe of the multimeter on the positive terminal of the solar panel. Similarly, place the negative probe of the multimeter on the negative terminal of the solar panel. Measure the open circuit voltage of the solar panel. The open circuit voltage is the maximum voltage that a solar panel can produce when there is no load connected to it. Take a note of the voltage reading displayed on the multimeter. This is the open circuit voltage of the solar panel. Compare the measured voltage with the rated or expected open circuit voltage of the solar panel. Short circuit test. Disconnect the solar panel from the charge controller. Position the solar panel towards the sun or light source. Arrange the moving coil ammeter with an appropriate range to measure the current generated by the solar panel. Note: to measure the current, connect the ammeter in series between the solar panel and the charge controller. This means that the current flows through the ammeter on its way from the solar panel to the battery via charge controller. Disconnect the positive terminal of the solar panel from the charge controller. Connect the disconnect positive terminal of the solar panel to the positive terminal of the ammeter. Now connect the negative terminal of the ammeter to the positive terminal of the charge controller. This connection makes to connect the ammeter in series with the solar panel and the charge controller. That is, connecting a positive lead of the ammeter to the positive on the panel and a negative lead of the ammeter to the load via the charge controller. positive terminal of the solar panel in the charge controller. Once the ammeter is connected in series, it will measure the current flowing through the circuit. The reading displayed on the ammeter represent the short circuit current ISC of the solar panel under the current sunlight conditions. Record the readings that display on the digital multimeter. Note the readings that display on the ammeter. The measured open circuit voltage and current values are 12 volts and 5 amps respectively. So the power becomes 60 watts when the voltage and current values are multiplied. Connecting the battery to the charge controller. Safety precautions. Ensure that you match the positive terminal of the battery with the positive terminal of the charge controller and the same for the negative terminals. Reversing polarity can damage the equipment. Identify the battery terminals with positive and negative sign in the charge controller. The charge controller typically has labeled terminals for connection. Connect the positive terminal of the battery to the positive terminal of the charge controller. Connect the negative terminal of the battery to the negative terminal of the charge controller. Connecting the power inverter to the battery. Identify the battery terminals on the power inverter with positive and negative signs or red and black terminals for positive and negative respectively. Connect the negative terminal of the battery to negative terminal of the inverter. Connect the positive terminal of the battery to the input of the DC circuit breaker. Connect the output side of the DC circuit breaker to the power inverter with the correct polarities, like the positive and negative terminals of the battery to the positive and negative terminals of the inverter. Connecting the solar panel to the charge controller. Safety precautions. Solar panels generate electricity when exposed to sunlight. The terminals of the solar panels carry this electrical current, and coming into contact with them can result in electric shock. Identify the terminals on the charge controller for connecting the solar panel with positive and negative signs. Connect the positive wire from the solar panel to the positive terminal on the charge controller. Likewise, connect the negative wire from the solar panel to the negative terminal on the charge controller. Tighten the screws securely to prevent any loose connections.
In this video, we have tested the solar panel, connected the battery to the charge controller, connected the power inverter to the battery, connected the solar panel to the charge controller. This concludes part 1. See you in part 2.